Many businesses spend more on cloud data platforms than they actually need to. In most cases, the issue is not the platform itself, but how workloads are designed and managed. In part 1 of this series, I walk through a simple example of how Databricks compute costs can be reduced without sacrificing performance. First, to make this realistic, I started by creating a sample insurance claims dataset containing 1 million rows, designed to simulate a real production workload. The dataset includes key fields as you would typically see in any healthcare or insurance environment: claim IDs to identify each record, member IDs to link back to policyholders, claim amounts representing the financial value of each, status indicating whether a claim is pending, approved, or denied, and dates showing when each claim was submitted. This kind of dataset represents a very common reporting workload. Organizations generate millions of these records every month, and analysts query them constantly for operational dashboards, financial reporting, and compliance audits. Because these queries run so frequently, even small inefficiencies in how the data is stored or accessed can multiply into significant compute costs over time. Next, I demonstrated a baseline query that aggregates data from the full table without any partitioning, filtering, or optimization applied. This is intentionally written the way many developers write queries when they're focused on getting results quickly rather than on efficiency. When this query runs, Databricks has to scan the entire dataset, even if the business question only needs a small slice of the data, such as claims from a single month or a quarter. In real enterprise environments, queries like this are extremely common, and they directly drive up compute usage because the cluster has to spin up more resources and process data that isn't actually needed to answer the question. You can think of it like searching for a single file by opening every cabinet in an entire office building, when you could have just walked straight to the right drawer. And lastly, to improve efficiency, I redesigned the table using Delta Lake partitioning based on the claim date column. Partitioning is a technique where the data is physically organized into separate folders or segments based on the values of a chosen column. In this case, the date the claim was submitted. Once the table is partitioned, Databricks becomes much smarter about how it reads data. In many cases, this kind of optimization alone can cut query costs by 50% or more, with no change to the underlying data or business logic. Please feel free to reach out to us if you have any questions, and we will see you in part 2.